We're going to talk about a very interesting concept, and that is the concept of load balancing. Now, you may have heard this term and maybe you're intimately familiar with it, but let's talk about it. So a load balancer is generally a device that usually evenly distributes traffic that's coming in from somewhere to multiple servers that are behind the load balancer. So you can think of the load balancer like a traffic cop or like somebody standing at the front of the passport line, directing people that come to a specific person that can help them. So you go to line number 1, you go to line number 2. As the traffic comes in, there's a load balancer to make sure that the lines are evenly distributed. We can look at that in a technical way with a graph like this. So in this graph, we actually have 2 load balancers. Traffic is coming in from the internet over port 80 at the top. Then we have our first load balancer called the public load balancer. We'll talk about that in a second. And there are 3 web tier servers behind the public load balancer. And so the traffic comes in and is distributed to them. And then those servers themselves need to communicate with some type of business tier. And there's an internal load balancer to distribute traffic over port 443 between the web tier and the business tier. So as you can see, there's a lot of redundancy built in this system. If anything happens to one of these servers, the system will continue to function. So when you're dealing with critical workloads, a single virtual machine often will not suffice. So either you have a lot of traffic and so you need to have multiple aisles open to serve people, or it is too important for there to be any closures. So if you think about public websites like Microsoft.com, the public facing website from Microsoft, there are hundreds and thousands of servers that are serving up the content from that site because it's just too important for a single server to be able to be responsible for it. But if you have a non-critical workload, let's say you have a server that just runs a job once a month, collects the files from one directory and copies them to the other. If that's a single server's job, then you don't necessarily need all that redundancy just for this non-critical workload. So what kind of options do you have in the cloud when you need more? So option number 1 is that there's always this scale up option. So you can take the virtual machine that you're using and you can find a bigger, more powerful virtual machine. Microsoft Azure and all the cloud computing platforms have a lot of options. We saw earlier in this course over 1,000 virtual machine options when you go to create a virtual machine. So if you're currently running a D2 instance with 8 gigs of RAM and 2 virtual CPUs, you can upgrade to the D4 instance with 16 gigs of RAM and 4 CPUs for double the price. Or you can go up to 8 or 16 or 32. There are options to go higher, and the pricing is just purely double when you double the power. You can see it goes on beyond 32 all the way up, in this case, to 96. So you can go up pretty high in terms of scaling up. But this is not still the recommended way of scaling when you have the need for additional support for a busy server. Now, one of the conditions here is when you reach that D96 server, you've got nowhere to go. Okay, there's no D128 or D256 that's available. There might be in the future, but you're already running a very big, powerful server. So there are a few downsides of using a single server, and I alluded to them before. It is true in computers and technology that sometimes you do need to reboot. So you do have a operating system update, a security update, the Azure itself needs to be updated, or on your side, you have an application that might not even require the operating system to reboot, but you have to stop traffic in order to upgrade an application to a new version and quickly test it before you turn on traffic again. So either Microsoft Azure or your own updates may require server downtime. There's also this unexpected downtime in terms of power outages, internet outages, and others. So you could have a single rack or the entire data center going offline for a couple of hours, and that would be inconvenient to you as well. As well, finally, you may have what's called a burst, which is a short, infrequent need for more power. And so there's other ways of doing scaling in terms of load balancing that are more convenient for traffic that comes in suddenly, as opposed to having to go from a D4 server up to D64 and then back down to a D4 because you're getting 1 hour of unexpectedly high amount of traffic into your application. So that was option one, is just to scale up and down. Option two is scaling out and in and out, to be more precise. So this is the diagram we saw at the beginning of this video, where you have 3 servers at the web tier and 3 servers at the business tier. It would be very easy to add a 4th or a 5th or a 6th server to either of those tiers if the demand for your application was to rise. You're also going to see less risk in terms of sudden downtime, and it's easier to even bring your application down for Azure system updates or Windows updates, because you can do it 1 server at a time. I did mention public and internal load balancers. So a public load balancer faces the public internet. It accepts traffic over port 80, 443, or a public port, and then it distributes it to the backend VMs using it. The public load balancer has a public IP address. And this is often used for websites and web apps and APIs, anything that is public facing. The internal load balancer, as the name implies, accepts traffic within the virtual network. It does not accept public traffic, does not have a public IP address. And this is used for backend servers, internal services like databases, or the middle tier of an application. So I mentioned before, if you do your scaling this way with 2 or more servers behind a load balancer, you get benefits, and one of them is the uptime availability of your entire application. We saw before, if one of those 3 servers went down, application would still function. Even if 2 of those servers went down, the application could still function. Now, maybe it would be slower or less performant, but you could suffer minor outages and still have uptime. Microsoft provides what are called service level guarantees, or SLAs, in terms of their promise for your virtual machine. So if you're using a single standalone virtual machine without a load balancer, and you choose one of the premium or premium ultra disks, they do have a uptime guarantee of 99.9% for the premium SSD, and which you would get a 10% credit in a month if they fail to meet that. If it's worse and it's only 99% uptime, you get 25% credit. And if in some disastrous way they only have 95% or less uptime in a month for a single standalone virtual machine, they'll give you your money back for that month for that virtual machine. So even without the load balancer, you do get some type of service level agreement. But when you start to use a load balancer, in particular an availability set, then you are getting not just 99.9% guaranteed, you're getting 99.95% guaranteed, which may seem like a small jump of just 0.5%, but that cuts your expected downtime in half. And you can see for 99 and 95, as though that remains in terms of your service credit. When you're using zones, 2 or more VMs in availability zone, again, that has to be probably behind a load balancer of some type. Then the uptime expectation goes to 99.99%, which is a massive increase in the availability for that service. Obviously, the more VMs you add, then your expectations should be to improve upon that even further. Now, within Microsoft Azure, there are 3 or 4 types of load balancers. There is the Azure Load Balancer service. So the fact that it's named load balancer might make it a little confusing when I talk about other types of load balancers. There's another load balancer called an application gateway, and we'll talk about the difference of that in a second. And finally, we have the front door service. And that is a whole range of services bundled together that is probably the recommendation. If you're looking at a web-facing property and you want a variety of things like CDN and load balancing across regions and things like that, front door service is probably going to be my default answer unless there's a really good reason not to. Like if there's a cost factor, then you might choose one of the other services. But if money is not mentioned in the question, I might be leaning towards front door services being what Microsoft recommends. Now, for the basic load balancer, there are different SKUs. You may hear the basic SKU, and in previous versions of this course, I mentioned it. That has been deprecated. So you cannot create a basic SKU anymore from scratch, although they still exist, and you'll never see this as being an answer on the test. The standard SKU is now the option. It has the service level agreement, so it has its own service level agreement on top of the virtual machines. It supports a network address translation in terms of NAT. You can do private links. It can do availability zones and things like that. For virtual network gateways, there's another type, but that's not covered on this exam. Now, I've mentioned, we saw with virtual machines and availability set, you get a certain amount of uptime guaranteed. In an availability zone situation, it's the most you can have in terms of availability. So if availability is your primary concern in the question, then I would look for the availability zone answers. And that could be standard load balancer. That could also be application gateway. So when you're creating these load balancers in an availability zone, you're going to get a couple of options to choose from when you're creating it. One is what's called zonal, Z-O-N-A-L, and that means you're placing the availability load balancer in a specific zone. And then you're going to need more than one to put it into zone 1 and zone 2 and zone 3. So you're talking about instances of the load balancer. For zone redundant, this means that Microsoft takes care of distributing it across zones, and that is a different, again, type of load balancer that you get to choose from. So using load balancers allows you to build what are called highly available multi-zone architectures. Now, I mentioned the types of load balancers. There is distinction between them as well. So you're going to look for this in the question. And the Azure Load Balancer is what's called a Layer 4 load balancer. That operates at the network layer, TCP or UDP. That means it has no knowledge of HTTP protocol. It cannot detect the domain name or the path. It's not inspecting the packets. It just understands TCP and ports. And so that's, if you need that kind of load balancer, then you would go with the Azure Load Balancer. If you need to understand paths, let's say the video subdirectory has its files on one server and the images subdirectory has its files on a different server, that would be an application gateway. Okay, so that's called a Layer 7 load balancer. It operates at the application layer. Finally, the front door service supports load balancing as well as SSL offloading and content delivery network support, things like that. Now, I haven't mentioned the traffic manager service. That counts as a load balancer technically, But all it does is it manages the Azure DNS in a way that if the person types the domain name into their browser, it goes and does a DNS lookup of that name, and the traffic manager service will give them a different answer based on their geographical location or some other algorithm. So Traffic Manager doesn't really operate as a load balancer. It operates outside of the cloud, really, and it's doing a DNS lookup, providing different answers to different people based on their location. Anyways, this video got quite long, but that's a good overview of load balancing within Microsoft Azure. Let's do a demo. One of the advantages of cloud computing is obviously the ability to add and remove additional resources to an application depending on demand. So if you design your application such that it can run on one or more virtual machines, you can easily add additional virtual machines, which will add capacity to your application. The way this is done is either through something like a virtual machine scale set, or you can have individual virtual machines organized in an availability set or in availability zones. But what you would need is some type of way to distribute traffic in front of that, and that is called a load balancer. So let us create a load balancer. So I'm going to go up to the search here, and we can see load balancers is a service. We don't have any load balancers currently. There are multiple different types of load balancers within Microsoft Azure. We're going to talk about the standard load balancer here in this video, and in the future video, we'll talk about application gateway and other services. So right now, I don't have any load balancers. So let us create our first load balancer. Now, like any resource within Azure, we're going to have this wizard interface here. We're going to have to create a resource group or put it into an existing resource group. I'm going to choose one of my existing resource groups to put this in. Let's give it a name. So AZ First LB as in a name. You generally want your load balancers to be running in the same region as your resources. There doesn't really make a lot of sense to have your load balancer in North America and your virtual machines in Europe, for instance. So you'll want to keep them close by. So I do have a VM running in Northern Europe, and so I'm going to keep my load balancer there as well. Now you'll notice that there's this message here for the SKU that the basic load balancer is retiring in September 2025. So if we pull in the documentation here, we can see that the basic load balancer will be retired, and they want people to upgrade to a standard load balancer prior to the retirement date. So we're going to basically, I think we're going to go start looking at standard load balancers as being the only type of load balancer we need to be concerned with. There used to be a basic load balancer. Again, it still exists, but it's being retired, and you should not consider it for any type of use at this point. Now you'll see that the standard load balancer has some additional features, including the ability to have IP-based backends. What this means is you could have either public on-premises servers or servers running in a different cloud, so Amazon AWS or Google Cloud servers, with your load balancer being in front. Now, like I said, you do typically want them to be close by for latency and lag, but it is possible to have a server of any type that is, at least it has an IP address that you can put as the back end. TCP, UDP protocols are both supported. The standard load balancer supports any virtual machine or a virtual machine scale set on a single virtual network. The basic load balancer required them to be in an availability set. And so this makes it a bit more convenient. You'll see the standard load balancer was required for SSL. There was zone redundant, zonal, and non-zonal options available. You could have your load balancer deployed to different zones. So there is, like you said, a lot of more features under standard, including having an SLA. It does cost money, and so the basic is being retired. Let's go back here. So I'm going to do a standard load balancer. Now you can see there is this concept of a gateway load balancer. That could be a load balancer in front of application gateways and other virtual networks gateways. So we're not going to worry about that in this video. When we're dealing with public versus internal, a public load balancer has a public IP address, and the resources behind it, typically you're going to want to hide from the public, so they will have private IP addresses. You do have the option of having an internal load balancer that does not have a public IP address, and that means that only other servers running in the cloud would then have access to those resources. I'm going to let it have a public IP address. And finally, you can see that we can deploy this to a specific region, or we can have this as a global load balancer that is not tied to a specific region. Even though it's deployed to a home region, it is run in a global level, not to a regional level. We'll just leave this as a regional load balancer. So load balancers have, let's say, three main components. One is the front end. So now we created this as a public load balancer. So that means we're going to want to put a public IP address in front of this. The back end are the servers that are running behind it. We're going to deal with that in the next video. And then there are the rules that dictate how traffic goes between the front end and the back end. So I'm going to click on this Add Front End IP. We do have to give it a name, and it can be sort of any name. So I'm just going to say PIP. You can have an IPv4 or IPv6. As you know, they've been saying for about 20 years that IPv4 space is full. And right now, I think all relevant of Microsoft services support IPv6. So it took a long time to get there, but if you did want to run IPv6, Azure fully supports it. We can run, be given a full IP address. If we did have an IP prefix, there's a whole thing within Azure where you can set up your own range of IPs, and that's called an IP prefix. We're going to just leave it as the IP address. I do need to create an IP address, so create new public IP, and it's just going to give me one. I don't need a zone for this, so I'm going to say this as being no zone. And again, there's no gateway involved, so we're just going to say save. So now we're going to have a load balancer with a front end. We're not going to set up, I'll do the back end in the next video, so we're not going to set up the back end pools just yet. What I am going to do is I'm going to deploy this without any rules or without any back end pool. So just say review and create, and say create. So we have a load balancer that has no servers and has no rules, but we can modify it to have those, and we'll do that in the next couple of videos. All right, so let's go and add the VM that I have into the backend pool, and we can set up rules and things. So we have a load balancer here. It has nothing in the backend pool, no rules. You see that it's a standard load balancer. And so what we're going to want to do is start to set it up. Let's go to backend pools. Now, a backend pool is a server or a group of servers, usually has to be multiple in order for this to make a lot of sense, that are going to handle the traffic that is coming through the front end of the load balancer. So you can imagine a user is on the internet and they type in www.website.com. It hits the load balancer first, and the load balancer has to decide where to send the traffic. You can have multiple backend pools, so multiple groups of servers, and you can set up different rules to send the traffic to different servers. So let's say you have one set of servers that handles the website, and another set of servers that handles images and big files, PDFs and videos and things like that. You can have those as two separate sets of servers, two separate pools, and two sets of rules. We're just going to keep it simple right now. We're just going to add a new backend pool, give it a name, call it pool 1, and we're going to point this to our virtual network. Like I said, I already have a VM, it already exists, and so we're going to point it to that. Now, you'll see that it says network interface card as the default. So this is using Microsoft Azure to know that there's a network interface card, or I can define it by IP address. If I knew the IP address, I could sort of define that. Let's just keep it as network interface card. I only have the one VM, so I'm going to select that. You'll see that it's got an internal IP address. It's going to choose that. If you don't see your server, it's probably something that is like not running in the same region. There's probably some other requirement that needs to be fulfilled. When we were dealing with basic load balancers, you had to be part of an availability set, and there was more restrictions in the standard. It's a lot easier, just point it to the VM. So I'm going to say save. Now, one thing that we don't have yet are rules. So we have our single VM sitting in the backend pool, but there's no way that traffic is going to get from the front end to the back end. So we do have to create a rule. And so we're going to call this LB rule 1. You can choose the existing front end address, choose the pool we just created, choose the protocol, which we'll choose TCP in this case for port 80. So any traffic coming over the HTTP port 80. You could do port mapping at this thing, but currently we don't. Now, there is this feature of health probes, which is if we had multiple servers in the back end, we could create a health probe that would then identify servers that are having health issues and take them out of the pool. So if there's 5 servers, 4 of them are great, and one of them is not responding to requests, you could have your health probe exist such that it removes that bad server. I'm going to skip that for now. We're going to allow all traffic to go to any server instead of having it what they used to call sticky sessions, where the client IP based on the protocol and the IP and the port would go to the same server every time. We're going to keep all the defaults here. Now, it's important to know that the rules have changed in Azure in the last couple of years, and virtual machines behind a load balancer do not have access to the internet by default. So we are going to have to, if we want this server to have access to the internet, we're going to have to create outbound rules to allow the pool members to access the internet. So I'm going to leave this as the default, but we're not going to create any outbound rules. And so this server is not going to have access to the internet at the current way that it's set up currently. Health probe, mandatory. So let's create a health probe. So this is called probe 1. And it's going to check port. It's just going to do a TCP check on port 80. So it'll open the port. If the port itself is connecting, then it's considered a success. A lot of times you may want to do a more sophisticated health check, which is like an HTTP or an HTTPS check, in which, let's say you're checking a specific HTML page that exists on your server, and that's what determines that it's successful. So you may have more sophisticated success or failure criteria. I'll leave it as a TCP check for now. Then we can say save. So that's it. At the very least right now, we have a front-end IP address. And if we navigate to this through our browser, the traffic should flow through this load balancer to the VM behind the scenes. Now, in order for the VM behind the scenes to respond, it has to have IIS set up, which I haven't done yet, so we can't test this at this very second. But the traffic should get through. If you send traffic to the public IP address of the load balancer, the backend pool will receive the traffic and be able to reply to it. Now, Microsoft does a pretty good job of providing documentation, Microsoft Learn and GitHub resources. I'm in GitHub right now under the Azure user and the Azure Quick Start Templates repository. A link will be provided attached to this video. The Quick Start Templates are an easy way to find literally hundreds of examples that you can deploy into Azure. Now you can see here there's been 30,000 commits over the years, and so this thing has just been growing and growing. There's even a website for it. I'm going to go into the Quick Starts submenu here, subdirectory. Now they've basically organized it according to the core technology here. So we can see API management quick starts are under one area, compute quick starts, the CDN, any kind of thing that you want to learn, you can go and check out the quick starts and you'll be able to find it. For this example, I want to look for a load balancer. Load balancer is under networking, so it's Microsoft.network. If I go into there. So I can see under the networking quick starts, again, there are dozens of things from ExpressRoute and Firewall, Bastion Service, Gateway. So I want to find a load balancer. I'm just going to do Control F. And I know that there are different versions of that. We've got IPv6 load balancer, cross-region load balancer. The one that we're interested in is called Load Balancer Standard Create. Now, another cool thing about GitHub is in this quick starts, there's just this button here that says deploy to Azure. There's also a visualize button. So now I'm going to go and deploy this load balancer. It's going to open up the portal and it's going to grab this quick start template for me. You can see that it's load balancer standard create from GitHub. I do have to fill in some details. I have to create a resource group for it. So I can say SJD new LB, put it as own resource group. I'm going to choose a region for it. I'm going to put this in East US 2. This project name basically is going to feed into the names of other resources. So this is like a prefix that's used when creating all the other resources. The location, you can see the default is going to pull from the resource group location. So this happens to be East US 2. I'll leave that. For the virtual machines, I have to give it user ID and password. So we can see it's defaulting to standard D2S instance type, which is pretty small, but that's fine with me. I can say review and create. And so I should be able to hit create. Now this is basically deploying the quick start template directly from GitHub, and I think this is pretty cool the way that I found a resource that I want to play with, and I'm just able to hit deploy, provide some details, and it goes off and does that work. So this is one of the really cool things about ARM templates. So while this is deploying and we can see the resources are being deployed here, let's go back to the GitHub repository for ARM, those quick start templates. And like I said, I think this ARM templates are really a neat way to deploy resources for testing. I think there is a certain amount of ARM template knowledge required for this exam. And so it is probably in your best interest to spend at least some of your time looking at the way that ARM templates are created. So pick something that you find interesting. Find the ARM template for that. There's some bicep in here as well, which is pretty cool. And look at the way that the ARM template is configured, the various properties of this JSON file, how parameters are passed, how resources are specified, because there is a good chance there's going to be a couple of questions on the exam relating to ARM templates. Not that you have to write them, more that you would have to understand what would go in a particular value or what would be the parameter name. So if this parameter name was missing, you should be able to determine what is the likely parameter name from a list of predefined options. So yeah, ARM templates, quick start. The link is attached to this video. Definitely check it out. So we have successfully deployed the load balancer, 3 virtual machines, 3 network interface cards, public IP, network security group, virtual network, using that template. And we can actually go into deployments of the resource group and we can see that the template deployment succeeded. And it took around 7 minutes to deploy all those things. A lot simpler to do than to set them up from scratch yourself. Now let's go into the load balancer. So the purpose of this video is to look at all of the things that can go wrong with a load balancer setup and what I would do to diagnose those. Now I want to start off by saying that there's really only 4 or 5 setting blades within a load balancer. We can see them listed as front end, back end health probes, the load balancing rules, and the network address translation rules. There's also the outbound rules, but that's not a very rare thing that people are going to set up outbound rules for traffic. Okay. So what can go wrong with your front end configuration? Well, of course, this is the IP address that's available to the world, right? So if you're going to enter that IP address into a browser, you're going to get some type of result. It's pretty cool that this template has a running web browser that says hello world and the name of the server as part of the configuration. So a thumbs up to the template that does that. That could be an Nginx or something type thing. So the IP address is what is connected to the world, of course. And so if you're using a domain name, you have to make sure that that domain name resolves to the correct IP address, that's all set up for domain resolution. Now the IP address is associated with rules. So this will be under load balancing rules. But if I go under this, I can see that it's my HTTP rule. Okay, that's what the rule that it's associated with. I'm going to do that later on here. Go into the next one is backend pools. So what can go wrong with your backend pools? Well, first of all, are you pointing this load balancer to the correct servers? And so you might have 1, 2, 3. You might have several backend pools that are all resolved to answer for this traffic. You can see here that one of my virtual machines is in a stop state. I just stopped it myself. And so one of the things that could be happening, of course, is that only 2 of your servers are doing the work and the 3rd server is never called upon, right? An unequal distribution of traffic. Now you're not going to see VM2 coming up on the web browser because it's stopped and because of the health probe. Health probe has removed VM2 from the rotation. So the health probe is what decides whether the backend pool is returning a normal response. So this is the health probe. If we go into it, we see it's a TCP health probe that's checking port 80. We also have the option for HTTP health probes and HTTPS health probes. An HTTP health probe checks a document can be retrieved from the web server, whereas the TCP health probe checks to see if it can connect to the port. So this is trying to connect to port 80. Now it's going to try it every 5 seconds forever. And if at any time the health probe fails, it's going to remove it from the rotation until the health probe succeeds. So if the problem resolves itself, then that's fine. Go to backend pools. This server that is deallocated has been kicked out of the pool based on the health rule. I can actually click on this and say start. But we're going to start that up, and then hopefully we'll see VM start to get responses from our calls. Now the 4th critical part of a load balancer, of course, is the load balancing rules, and we saw the front-end IP address is connected to this rule. And this rule basically takes the front-end address and will send all traffic from port 80 inbound to port 80 on the server. So you're going to have make sure that your server is listening on that port. This is the pool that contains the virtual machines. So make sure that your load balancer rule goes to the right pool. Again, the health probe has been chosen here. Now, session persistence is whether the same user gets sent to the same server every time, or whether you can have any server responding to that user. This concept of idle is basically the client and the server have this open connection as opposed to it being closed and then having to be reopened. All right, so we're going to leave the load balancing rules as they are. The final section is NAT rules. Now, we don't have any set up, but network address translation is more specifically when you're taking in traffic over one port and sending it basically a port mapping to the target port. It is, incoming traffic sent to a selected IP address and port combination to a specific virtual machine, as opposed to the whole group of them. So if you're looking for that kind of setup, then this is where you're going to debug any kind of problems with that. We don't have any of those. Now, if you do need to configure rules for traffic leaving the virtual machines, traveling through the load balancer, then you can set them up in the outbound rules here. So in terms of debugging, your front end being set up correctly with the correct load balancing rule, your back end being set up correctly, your servers all in a running and proper state, your health probes pointing to a proper location that would successfully tell your load balancer whether or not it is healthy properly. And finally, the rules themselves that tell you which traffic can get through and which traffic cannot. So for instance, right now we don't have an HTTPS rule, and so that would be basically blocked by the load balancer. Now, I should also mention that you can set up an alert process so that if there's ever any health probe issues, backend servers that are not responding, that a particular alert group is going to be notified, or an action group here. So we can say the resource is the load balancer. Under the condition, we can choose the, we can see here some of the signals available, health probe status being 1, the number of bytes being sent through, the number of packets, whether or not the load balancer. These are more administrative. You wouldn't necessarily set these up, but health probe status is a good one. And so we can see the health probe was having problems. I restarted the server, and number of problems are going to go up and go down, right? So we can choose the, we don't need to, basically we can say more than 5 failures in 5-minute period means that you're going to get a notification in your alert, your action group here. And that could be an SMS message, it could be an email, that could be some type of job that kicks off, etc. So setting up alerts is another way of figuring out health probes are failing and your load balancer is having difficulties. Now, the load balancer that we created a couple of videos ago is actually what's called a layer 4 load balancer, and it operates on the layer 4 of the OSI transport model. That means that it understands the difference between TCP and UDP. It understands IP addresses, NIC cards, but it doesn't understand applications. It doesn't have a grasp or a concept of the packets that are being sent to the server. It doesn't have the ability to inspect those packets and make decisions based on the contents of those packets. It's purely just IP addresses and ports. Let's say you need the load balancer to be able to look at the path of the URL and send traffic to one server if the URL contains a certain path, and a different server if the URL is slightly different. Okay, you could have different domain names with the same IP address, or just paths underneath that domain name. Well, then you need what's called a level 7 or a layer 7 load balancer. And in Azure, that's called an application gateway. So if we go up and we search for application gateway, we're going to see application gateways. It is a load balancer, but again, it operates at a higher level. It understands that you're dealing with a web app, and it understands you can look at the contents of that packet and make decisions based on that. So I'm going to say create application gateway. I'm going to put this into the same resource group that I previously did, and we're going to call this demo app gateway. I'll leave this in Northern Europe with the other load balancer and the VMs. Now, just like with load balancer, there are tiers to this. Okay, we see that you have V2 standard, the web application firewall V2. Now, the application gateway, there used to be a V1 that was deprecated in 2023, announced in 2023. By April 2026, you should not be using the V1. Again, you cannot even pick it from the This web application firewall includes a basic firewall which can understand when somebody is trying to do basic SQL injection attacks, cross-site scripting attacks. There's a list of industry standard attacks to websites that a web application firewall can protect you against. Now, this application gateway can scale. So if you are expecting a lot of traffic and you may need more than one application gateway, then you can certainly turn on auto scaling at the application gateway level. I'm not going to. I'm just going to leave one instance, and we're going to deploy it across zones here. Again, we can choose IPv4 or both, and we can choose HTTP2 standard HTTP protocol instead of 1.1. It comes in as 2, and then it gets translated to 1.1 for the backend. Let's leave that turned on. We have to deploy this into a virtual network. I'm going to deploy it into my virtual network that exists. Now we need to have, it has to have its own subnet. So having a VM on this is not going to work. So we need to say manage subnet. So we're going to create a new subnet just for our application gateway. We give it a name called My Application Gateway. It's not, you can give it a name, anything that you want. We're going to, that's quite a big range. So you see it includes 256 addresses by default from 10.0.1.0 to 10.0.1.255. So we're going to leave everything with the defaults here and say add. Now that that's created, we can go back to the previous screen, and we can choose the new application gateway subnet. Now we have a couple of IP addresses, the VM and the load balancer. We have to create a third one, I guess. App gateway IP. . So we're going to create a pool here, but we're going to leave it empty for now. We'll add targets in a second. Now, just like with a load balancer, standard load balancer, we do need to have rules to travel traffic from the front end IP to our back end pool. And like I said, this is a level 7 load balancer. And so this is going to understand, it's going to understand that there are HTTP or HTTPS, and there's going to be maybe basic rules that we can add to it. So I'm going to say priority 100. We have to create a listener. This is going to be listening on the front end over IPv4 for port 80. Remember, this is for applications. And if we choose the backend target, we can choose pool 2, and we can set up some settings. So all traffic coming in port 80, we're not going to have path specific traffic. Like I said, application gateway can support that. And say add. Now, if we had multiple pools, we could have this path-based rules, which we won't do. Now we say review and create. So you'll see it's very similar to a load balancer, but again, this operates at a different layer of the OSI model. And you're dealing with containers, you're dealing with web apps, you're dealing with things that can understand HTML, HTTP, and not just IP address-based traffic. So I think we're going to leave that there. If you want to add virtual machines and add them to the backend pool, you're certainly free to do that. But this is the example of creating application gateway, how similar it is to load balancer, and indeed the differences.